So, how do we set up a reverse proxy? What is a reverse proxy? You might have heard of the term proxy before on the internet, and maybe we should talk about that first. So let's start with kind of you're out here just minding your own business. You're at the IP address of 1.1.1.1, just an example. You make a request, you want to get to Google, so you go out to the internet, net, blah. And it's just kind of a cloud, and then that gets to Google. Alright, so very basic web request. Your 1.1.1.1, make out through the internet through to Google. Very straightforward. Now, let's say you had a proxy in this. So a proxy, let's say this is at 2.2.2.2. And so you cut this out and you connect to that, and this connects then to the internet, and that makes the request to Google. As far as Google sees, the request is coming from 2.2.2.2, not back here. And in theory, Google can't pierce through that and know, and that's kind of iffy if that's really true or not, but generally they don't bother trying. So, why would you want to do this? Well, one reason is you might want to filter content. Let's say there's ads you want to filter out. Instead of using a browser plugin, instead you have the proxy do it. It just blocks the request to the common ad networks. It could just block other websites. Businesses might want to do this, that they don't want you browsing porn or doing games at work. They might use a proxy to block that content. Might also be used for caching data. So this was more common back in the days when we had dial-up and speeds were kind of limited. But if you made a request to CNN.com, and then someone on your network also made another request to CNN.com just a minute later, chances are that content doesn't change too much. So it's just going to cache it on the proxy, and then when the second request comes in, it just responds with what it had before. It makes it much more efficient going out to the internet. That we don't see quite so much now that everybody has broadband, but it's still possible to do it. Could also be for privacy. Google, in theory, can't pierce through this. There's a lot of VPN services out there that can do this sort of thing and help protect you for privacy. So that's one possibility as well. Now, what's a reverse proxy? Reverse proxy wouldn't be here. It's something Google would set up themselves. So instead of this, you're once again making the connection to the internet. But this point where you're getting to Google, this is just a single entry point, and to have just one computer handle all of Google's massive search results that they do every single day, that's insane. You would never do that. What they have is a whole bunch of servers back here. And then this system just routes packets in turn. So first request that come in goes to this one, second request to this one, third request, and it just cycles through them. And that means this, all it has to do is just route requests. And these are doing all the expensive operations of handling your search requests, and it just responds back. And as far as you know, this is the only thing you're communicating with. That's a reverse proxy. Now, why would you want to do this at home? You probably don't have these massive application servers or anything like that you need to do. One thing, if you're into a lot of Internet of Things type projects and home automation, you might want this so that you have maybe one computer that's controlling your garage door, something else that's turning lights on in your kitchen, something else that's rolling up the blinds in the living room, and so on. Instead of having a separate IP address publicly available for every one of those, which you can't really do on IPv4 anyway, your ISP just won't assign you that unless you spend a whole chunk of money, you just have one entry point. you only need one IP address, which you can get very easily. Of course you have one. You're on the internet. And then this also provides a single point where you can manage your TLS certificates, SSL, otherwise encryption. That will mean the connection is encrypted up to this machine. It won't be encrypted internally, which has trade-offs, but generally I kind of prefer this setup. Also a single point to manage your passwords for all these things. And it is generally just a little more efficient way of doing it. So what are you going to need for this project? Raspberry Pi will do just fine. This is a Model 3. I would suggest at least a Model 2 just because multi-core processors are going to be a little bit more responsive. And you probably don't want a 0 as well. I don't recommend using Wi-Fi for this just because Wi-Fi is a little bit unreliable. This is going to be your single point of entry, remember. So if this breaks, you're not going to be able to communicate with all this outside of your house. So I recommend just use a hardwire and maybe have Wi-Fi enabled just as a backup connection. So you want a Raspberry Pi, you want Ethernet cable, and case is a very good idea. This one has the heat sinks on it with a nice little fan that came with it. I rather like that. And of course you're going to need the SD card. Got a 32 gig one in here, which is way more than you need. 16 gigs is plenty. And of course the power supply, which this one, this came with the case, which I rather like, and it's got a power button too, which I have not seen these on Raspberry Pi power supplies before, and I rather like that. So that's nice. So that's all you need for this. Let's get into it. Now there's a few things that you're going to need to know how to do for this project, and I won't really cover them in depth here for various reasons, and we'll just kind of get into that. So the first thing you're going to need to do is give your Raspberry Pi a static IP address. Generally this is done by taking the MAC address on the Pi of the interfaces and telling it you want a specific IP. And be sure to write this down as you're going to need it. So look at the highlighted portions here. We are using the ifconfig to dump all the information about the interfaces. And you see here the ETH0 and also WLAN 0, that is the wired Ethernet and the wireless Ethernet respectively. And then highlighted in both of those is a MAC address. It's a series of hexadecimal digits. And you want to take that and put them into your router, and that will assign a static IP address to it. Routers are all a little bit different, so I can't really show you exactly how to do this for your router, but if you look up the documentation, hopefully you'll be able to find it. Also, you're going to need to be able to forward TCP ports to the Raspberry Pi. You're going to take that static IP address and ports 80 and 443, that's plain text HTTP, and then TLS HTTP. And you just have all incoming information on those ports is just forwarded to the Raspberry Pi on those same ports. You're going to need a domain name. It's probably best if you purchase your own domain name. I always like to have my own. And then you're going to need to set up dynamic DNS. Now your ISP doesn't always assign you the same IP address. Generally they will, but it's not necessarily a safe assumption unless you've actually signed up for that. And usually that's only on business accounts and you pay extra money to do that. So you're going to need a dynamic DNS service. Usually, sometimes these are free, sometimes they're like $5, $10, $15 a month. And what that will do is periodically ping that service and tell them what your current IP address is. And then it's going to set up the DNS records to point to you. That's what DNS does, is that you take a name like example.com and it translates to an IP address for people to actually look you up. So that's what you're going to need to set up before doing this.
And there's various ways to do this. I can't really go through them all, but if you look around, you should be able to find how to do these things. Once you have the system installed, you'll want to install the following. And make sure you do first an apt-get update. I've already done it on the system, so I'm not going to run it now. But then you want to install Nginx, Apache 2 utils. That contains some of the password management tools we want. We're not going to install Apache 2 itself. And then you also want Let's Encrypt. And that will get you your SSL certificates through the Let's Encrypt system, which is completely free and will work on pretty much any browser you need it to. And there's likely to be some dependencies here that you need to install, so this is going to take a little while. So just hit yes and let it do its thing. Now we're going to set up a Let's Encrypt certificate. So to do that, we already have certbot installed. We need to do the command certbot. Be sure to do this as root, so we have sudo at the front. And then we need our domain name. I'm going to use this as if you want to forward this to a garage bot of some sort. And we'll just put in example.com. So just fill that in with whatever domain name you set up. And then this will be in manual mode. And then for this, we're going to use a preferred challenge, a DNS, and cert only. Now, what this is telling Let's Encrypt to do is that we're going to do a challenge over DNS, and that means to ensure that we actually own the domain to be able to get a certificate, it's going to use the DNS method of doing that, and we'll go through how to actually do that. And the cert only just says that we're going to register a certificate and we're not going to set up the web server directly. We're going to do that on our own rather than having certbot do it for us. So we just run that command. And it's going to tell you that you're going to have your IP address log. That is kind of an inherent part of the process of setting this up. So we just said yes. And it's going to tell us that we need to set up this DNS TXT record. Now there are different records in DNS. When you went to set up your domain name, you probably saw an A record, and that means that A record just says this domain is associated to this IP address, and then people can look that up. But there's other types of records as well. So there's a quad A, AAAA, that's for IPv6 addresses. There's also these TXT records, and these are just kind of data that you can put in there for various purposes. And it's giving you this random string here. And you're going to need to copy and paste that into your DNS setup and send that out there, and then wait for it to deploy. Generally that takes 15 minutes to maybe an hour. And you're going to want to wait until that's actually set up. So just let this sit here for a while and then hit enter. Once that all goes, this should all be set up. You should have a certificate. If you want to password protect your system, this is how you're going to do it. So go into cd/etc nginx. We're already there. And then we're going to create a password directory to store this. CD into it, and then we're going to use the HT password that came from the Apache tools, and we use C to create a new file, and we're just going to call that garage. That'll be the name of the file, and we're just going to type in a username, and it'll ask for a new password, and retype it, and then if we cat this file, we can see that it has the encrypted password inside it with our username. Go back down a directory, and then we want to chmod this to 700. It's just a good idea that only the web server user is the only one that can do this, as well as root on the system, of course. So we chmod at 700, which means only the user has read-write access to this file. And actually, we want to put in a -r. That'll be recursive, so all the files underneath that directory will have this same setting. And then we want to have it owned by the web server, and Nginx under the Raspberry Pi runs under this www-data user and group. So that's what we're going to set here. And now if we list this directory, we see right here we have this password directory, and it's read-write execute set only for the given user. And the owner on that is www-data as well as the group. And that's how you would set that up. Now we're going to configure Nginx itself, and we do that by going into this sites available directory. And we can see I've got this example set up already, and we'll just go through this line by line. So this server block here that you start with is just telling it that we're going to start listening. This is kind of its own little world for the server. And this server is going to listen on port 80. That's the plain text HTTP port. And whenever we see a host name with garage.example.com or just plain garage, that's kind of a nice shortcut to have sometimes. This is the server that's going to be used for that on port 80. But all we're going to do with this one is for anything under location /, we're just going to return a redirect. That's a 301. And that's going to redirect to our HTTPS version. That way we're encrypted. And we just, these variables here just pass along the host and request information to the encrypted version of the server. And that's what we configure down here in this server block. So we're listening here on port 443. That's the SSL block, or TLS as you may call it. Server name is just the same as what's above, and then we're turning SSL on. This is the path, these two configurations are the path you need to the SSL certificate and the certificate key, two different files. That's going to be set by Let's Encrypt when you did the configuration for that. And then we have some SSL options. These set various things that tell it what version of TLS and SSL that you want to use. And then the strict transport security header is a pretty good idea to have. When we do that redirect to the SSL site, it's then going to send this strict transport security, and every time the browser visits this site from then on, it's going to remember this transport security setting, and it will automatically go to the SSL site from then on. And then any location under /, which is basically everything. Here we set up the authentication that we did before. So this is the password. This is the auth basic. This is just a little bit of text that pops up in the browser. It's not that important. Just generally you have to have it there and fill it with something. Then here we have the path to that password file we built before. And then we have to set some proxy settings. So the host is the domain name, and we have it just set to the variable so that it will automatically be filled in by Nginx. And then the real IP address. So when the actual server that you're setting up sees the IP address, it's just going to see the IP of the front-end proxy, which isn't that useful. This sets it to the actual IP address of the client doing the request. Forwarded for is also something that chains along if there's other proxies. It's just a good idea to fill this in. And then the actual scheme that the client used. And then the proxy pass here is the IP address that you're sending to. So you can see here, we're just passing it along in plain text. That means all the communication between the Nginx reverse proxy and the actual application server, that's going to be unencrypted. Which is generally a good thing. That's all in your internal network. And it's not necessarily safe to assume nobody can tap into that, but you know, somebody has to bother. So you can try setting it up on the other end if you want, but you can do it plain text just fine. This is the IP address of the target, and then the port of whatever is running on the other side. And then just a timeout. It's going to wait 90 seconds, and if the other server doesn't respond, it's going to send a timeout message back to the client. And then proxy redirect. This is just telling Nginx that we're going to do the proxy. So we put in the domain name here, and then we're going to tell again that we proxy this way. This should be the same as what's in proxy pass for that part. And that's the whole configuration. Last thing we need to do here is we put it in sites available, but Nginx doesn't actually activate or anything if you just do that. You have to go into sites enabled here. And here we can see it's a link to the actual file. So if we do down to sites available, and then the garage file, or the example domain rather, now we get a soft link to that example domain. And now when Nginx starts, it's actually going to read that domain. So we can actually put our configs into sites available and not activate them. And then we make the link in this directory, and that will actually bring it up into the Nginx config. And of course we can delete that link, but still keep the original file if we want to disable that domain. Once we're done setting up our links, we're going to want to do a config test. So we want to run this as root and just do a -t on Nginx. And it's going to tell us if all the syntax is okay. So if we messed up a path somewhere or we have our syntax off, it's going to warn us here. And if we had just restarted it, it would shut down the server and then see that you have a problem, and then it's not going to bring it up, and now your system is down. So you want to do this first to double check that your configuration is correct. Now we want to set up Nginx to start up at boot whenever the system comes up. So we do that by typing systemctl. We are enabling Nginx, and that puts it into your startup scripts. Now if we look at the running processes, we can see Nginx is not running. It's just showing the grep that we did to search for Nginx. So what we do to start it up is type service Nginx start. And then if we run that again, we can see there's a bunch of processes running for Nginx, and our system is up. Now to test this, we go to the actual site of the domain we put in. And we can see here where it says required, that's the text we had put in, if you remember earlier, to the basic auth. Not too important, it's just, you know, it's going to show up there. And then we put in our username and password. And if everything works right, I just have a little hello world set up on this, and that is coming from the server. So it's going through my Nginx proxy. That's sending it on to an application server that's actually generating this hello world, and then it sends it all the way back to the browser. And you should be able to access this anywhere in the world. So that's how you would set up an Nginx reverse proxy. Go out and have fun. So if you enjoyed this video, please subscribe to this channel. It really helps me out. And if you really like it, maybe check out my book on Leanpub. Programming the Raspberry Pi with Perl goes into a lot of projects and everything you need to know about how to do that. So thanks for watching.